Periodic classification of elements. Classification on the basis of states of matter cannot be justified because bromine and mercury, which are liquids at room temperature, cannot be placed in the same group. William Prout in the year 1815 suggested that atomic mass can be used as the basis for classification of elements. First attempt of classification was made by Dobereiner. Dobereiner formed a group of 3 elements called triads having similar properties and arranged them in the increasing order of their atomic masses. Law of triads does not help in classifying all the known elements. However, the law of triads gave a clue that atomic mass can be used as the means to find suitable laws for the classification of elements. Newland arranged the elements known at that time in the increasing order of their atomic masses. He found that when elements are arranged in the ascending order of their atomic masses, starting from any one, every 8th element is similar to the first in chemical properties. This is the essence of Newland's law of octaves. The word octaves is used in music. This is the reason for calling it the law of octaves. Newland's was ridiculed for comparing chemistry with music. However, Newland's contributed the word periodic in the classification of elements. According to Dmitry Mendeleev, the properties of elements repeat at regular intervals when arranged in the increasing order of their atomic mass. Mendeleev altered Newland's law of octaves by replacing the word octaves by regular intervals. Mendeleev's periodic law is stated as: the properties of elements are periodic functions of their atomic mass. Mendeleev was able to predict the atomic mass and properties of the elements even before their discovery. Periodic table of Mendeleev helped in the discovery of new elements like germanium. Modern periodic law is based on atomic number and not on atomic mass to solve the problem of isotopes. The modern periodic law, as stated by Moseley, is: the properties of elements are periodic functions of their atomic number. The meaning of isotope is iso same, tope place. Atoms having different atomic masses with the same atomic number are given the same place in the periodic table. Group 18 is also called zero group because the valency of these elements is usually zero. They are called noble gases instead of inert gases. Elements like argon, xenon have 8 electrons in the outermost shell. This type of electronic structure is called octet structure. Stable gases or noble gases or inert gases of 18th group have either completed shell or outer octet structure. In each period of the periodic table, the elements are arranged in the ascending order of their atomic number. A part of 6th and 7th period from atomic numbers 58 to 71 and 90 to 103 respectively are kept separately at the bottom of the periodic table. Elements of the separated periods are called lanthanides and actinides. Periods are formed according to the way in which electrons get filled up in different shells and orbitals. Based on electronic configuration, all the elements in the periodic table can be grouped into 4 general categories. They are S block, P block, D block and F block elements. To find the group number of an element, the electron capacity of S, P, D and F orbitals have to be considered. Atomic size. The distance between the center of an atom and its outermost shell is taken as atomic size. Ionization energy. Ionization energy is the energy required to remove the electron from the outermost shell from the free and isolated atom of an element. There is inverse relationship between atomic size and ionization energy. Electrochemical nature. Atoms which give up electrons easily are called electropositive. For example, sodium atom. Atoms which receive electrons easily are called electronegative. For example, chlorine. Metallic nature. Germanium has characteristics of non-metal and metal. Elements which are not distinctively metals and possess some physical properties of non-metals are called metalloids. Advantages of periodic table. Study of chemistry is simplified and organized, leading to easy access of data of the elements. It was possible to predict the atomic mass, some of the properties, and other details of elements which are yet to be discovered. Many elements were discovered during the lifetime of Mendeleev. Interpretation of trends and periodicities of properties of elements provided a clear understanding and proof for the atomic behavior. Interpretation of trends and periodicities of properties of elements provided a clear understanding and proof for the atomic behavior. It is possible to predict the properties of elements by considering the position of elements in the periodic table. On the other hand, properties of an element help us to predict the position of an element in the periodic table.